Hello, welcome back to today's session. In the previous session, we had introduced ourselves to what is traveling salesperson problem, and we had seen an algorithm or a procedure of how to solve the problems on traveling salesperson. And I had also told you in today's session, I'll be solving one or two problems on traveling salesman problem, right? So hope you people are ready. So when you are listening to this video, I expect a small thing from you. If possible, uh, parallelly solve the problem with me so that your confusions will be avoided, right? You can also have a pen and paper with you, listening to the video. You can try solving the same problem along with me so that it will be easy for you to understand. Fine. So let us step into the first problem. The first problem says a traveling salesman has to visit 5 cities. He wishes to start from a particular city, visit each city once, and return to his starting point. The cost of going from one city to another is shown below. So this is the cost matrix. So decision variable is cost. Find the least cost route. Okay, the cost matrix given, as I said, in traveling salesman problem, the primary diagonal elements will be infinity, right? Do you observe? The primary diagonal are all infinity. So the given cost matrix is first row, that is from A to A infinity, A to B 4, A to C 10, A to D 14, A to E 2, B to A 12, B to B infinity, B to C 6, B to D 10, B to E 4, C to A 16, C to B 14, C to C infinity, C to D 8, C to E 14. D to A 24, D to B 8, D to C 12, D to D infinity, D to E 10, E to A 2, E to B 6, E to C 4, E to D 16, and the last one E to E infinity. So let us try to solve this problem. So I've just copied the problem as it is, and because the rows and columns do not have zeros, row reduction has to be done. So first step, row reduction. The first row least element is 2, second row least element is 4, third row least element is 8, fourth row least element is 8, fifth row least element is 2. So I subtract these minimum values from all the values and I write it infinity minus 2. You subtract anything from infinity, it will remain infinity only. So infinity minus 2, infinity. 4 minus 2, 2. 10 minus 2, 8. 14 minus 2, 12. 2 minus 2, 0. Next row, when I subtract, I get 8, infinity, 2, 6, 0. The next row, when I subtract 8 from it, I get 8, 6, infinity, 0, 6. I will use a pointer. The fourth row, when I subtract 8 from it, so I get 16, 0, 4, infinity, and 2. From the last row, when I subtract 2, I get 0, 4, 2, 14, and infinity. Now check whether all columns have zeros. First column has a 0, second column has a 0, third column does not have a 0. So because it does not have a 0, I will have to perform column reduction. So column reduction step. So from the first column minimum is 0, from the second column minimum is 0, from the third column minimum is 2, Fourth column minimum is 0. Fifth column minimum is 0. So when I subtract 2 from this particular column, I should get 6, 0, infinity, 2 and 0. Okay. So I've written the same thing here. Infinity, 2, 6, 12, 0, 8, infinity, 0, 6, 0, 8, 6, infinity, 0, 6, 16, 0, 2, infinity, 2. Last row is 0, 4, 0, 14, infinity. Okay. Till here, no doubts at all. Now, we are going in for allocation making. So in the first column, I have only 1 0. So I make an allocation. And in the same row, I had one more 0. I'll cross it. Okay. Now look at the second column. It has 1 0. Make an assignment. In the same row, I don't have any zeros. So leave it. Third column, I have a single 0. Make an assignment. In the same row, I have one more 0. So cross it. Coming to the fourth column, I have a single 0. Make an assignment. No zeros in the same row. Fine. Go to the fifth column. I'm left out with a single 0. Make an assignment. No other zeros are cancelled. Okay. Till here, it was very much similar to your assignment problem. Now the difference starts. So for all the allocations that you have made, you are supposed to find out the allocation penalty. So how do you find out the allocation penalty? It is the minimum of the column and the row in which the allocation is made. See, in this column, minimum element is 8. So I write 8 first. Then look at row wise. I have a 0 which is minimum. So 8 plus 0 is the penalty. Now coming to this, in the column minimum is 2, in the row minimum is 2. So the penalty is 2 plus 2. Coming to this allocation, in this column I have a 0, in this row also I have a 0. So 0 plus 0 is the penalty. Now coming to this allocation, in the column 6 is the minimum, in the row also 6 is the minimum. So 6 plus 6, 12 is the penalty. Now coming to this allocation, 0 in the column and 2 in the row are the minimums. So 0 plus 2 is the penalty. So out of all these penalties, 8, 4, 0, 12 and 2, which is the maximum penalty? 12. So this should be considered as my root. Okay. That means to say from C, I eliminate the C row and the D column. That means to say I am traveling from C to D. So C to D I am traveling. So I cannot travel back in the same direction or in the same route, right? So I will set D to C is equal to infinity, right? The next problem that I solve will not have C row, will not have D column. But D to C, this entry 2 will become infinity. So let us see, right? The next problem became infinity. From A to A infinity, I have copied it as it is. Then A to B 2, A to C 6, A to E 0. So the A row was infinity 2, 6, 0. Infinity 2, 6, 0. Now look at B row. B row was 8, infinity 0, 0. 8, infinity 0, 0. Next coming to the D row, it was 16, 0. This 2 will become infinity. So I have 16, 0, infinity 2. See, 16, 0, infinity 2. Now coming to the last row, it is 0, 4, 0, infinity. 0, 4, 0, infinity. Right? I have copied the same matrix. Now check whether all rows and all columns have zeros. First row has 0, second row has 0, third row has 0, fourth row has 0. Column wise, first column has a 0, second column has a 0, third column has zeros, fourth column has zeros. So there is no need for row reduction or column reduction. Straight away I can go with allocations. So I'll come for allocations, look into the first column. I have a single 0, make an assignment. Then come to the second column. I have a single 0, make an assignment. When I made this first assignment, the 0 in the same row got cancelled. Okay. Next, coming to the third column, I have a single 0 because this is already crossed off. So make an allocation here and cross off the 0 here. Okay. So now coming to the fourth column, I have a single 0 left. So make an assignment. Now compute the penalties for all this. Column minimum is 8, row minimum is 0. So 8 plus 0. Coming to this allocation, column minimum is 2, row minimum is 2. So 2 plus 2. Here column minimum is 0, row minimum is also 0. 0 plus 0. When I come here, column minimum is 0, row minimum is 2. So 0 plus 2. So what are the penalties that I've got? 8, 4, 0, 2. Which is the highest penalty? 8. Obviously 8. So make this as my route. So where am I traveling now? From E, I am traveling to A. So E to A will be my travel route and reverse route will become infinity. So I will have to set this A to E as infinity. So this portion will become infinity. Okay. So now the next problem that we rewrite will have 2, 6, infinity as the first row, 2, 6, infinity as the first row, infinity 0, 0 as the second row, infinity 0, 0 as the second row, and the third row is 0, infinity 2. 0, infinity 2 as the third row. Okay. Now check whether all rows have zeros. No, first row does not have a 0. So perform row reduction. Minimum element is 2. Second row minimum is 0. Third row minimum is 0. So the result that I get after performing row reduction is 0, 4, infinity, infinity 0, 0, 0, infinity 2. Now check whether all columns have zeros. First column has a 0, or first column has 2 zeros. Second column has 1 0. Third column has 1 0. So all columns have zeros. So straight away I can go for allocation. So first allocation I'll make in the second column because it is the one which has single 0. So I'll make an allocation here and cross off this 0. Fine. Now in the third column I don't have a 0 at all. Check the first row, first column. It has 2 zeros. The first 0 that I encounter, I'll make an allocation. The other 0 I'll cross off. Now find out the penalties. So the penalties are 0 in the column wise, 4 in the row. So 0 plus 4. For this, 4 in the column, 0 in the row. So 4 plus 0. Here also the penalty is 4. Here also the penalty is 4. Now which one to choose? Choice is yours. Arbitrarily you can choose any one. You will get the correct answer. But what I do is, I always look for continuity. See, in the previous step, I have already traveled from E to A. Presently, I am at A. So, instead of taking B to C, I will take A to B so that I will get continuity in the route. That's all. But this is not a compulsion. You can take B to C also. Then also you will get the answer. Okay. So, A to B I take. So if at all I am traveling from A to B, B to A I cannot travel, so it will be infinity. B to A option is not at all there, so I need not bother. So my resultant matrix now is 0, 0 in the first row and infinity 2 in the second row. Infinity 2 in the second row. Now check whether all rows have zeros. No, second row does not have a zero. So the minimum is 2. Subtract it. So the resultant matrix that I get is 0, 0, infinity 0. Okay. Now what am I supposed to do? Allocation step. First column has a single 0. So make an allocation, cross this 0. So second column has a single 0. Make an allocation. Fine. Now find out the penalties. Column wise minimum is infinity. Row wise minimum is 0. Here column wise minimum is 0. Row wise minimum is infinity. So for both I get infinity as the penalty. So what should I do? Same old procedure. Arbitrarily choose any. In the previous case, I had chosen A to B. Currently, I am at B. So I will pick this path for my convenience. So B to C, I will travel. So if at all I am traveling from B to C, C to B should be infinity. C to B is not there, so need not bother. So the resultant matrix that I get is D to E with 0. Right? The matrix that I've got is D to E is 0. So if at all it is a single 0, no need to bother at all. Straight away cross it. So my path is D to E. Okay. So now the entire problem, entire matrix has vanished. That means I have found out the final solution, or the final solution is obtained. So where did I start from? Which was my first route that I got? So I started from C. So I am writing the path. So finally, when I write the answer, so I am traveling from C to D. So from D, where did I go? In this step, I get from D to E, I went. From E, where did I go? E to A. You see here, I am moving from E to A. So after moving from E to A, from A, where am I going? A to B, right? So from A, I am moving on to B. From B, where should I go? B to C. B to C. Have you reached the starting point? Yes, you started with C, you ended at C. Have you visited all other cities exactly once? A you have visited once, B you have visited once, D you have visited once, E you have visited once. C is the starting point, so it is appearing 2 times. So I have got the route. So what is the next job? For this route, I am supposed to write the cost. Look at the original matrix. C to D, what is the cost? 8. D to E, 10. E to A, 2. A to B, 4. B to C, 6. So 8 plus 10, 18. 18 plus 2, 20. 20 plus 4, 24. 24 plus 6, 30. So the least cost of traveling the route C to D, D to E, E to A to B, B back to C is 30. Fine. Is the problem tough? I think the problem is more fun to solve. So let us take one more problem. Right. So the next problem given is a machine operator processes 5 types of items on his machine each week and must choose a sequence for them. He has to identify which type of process he will do first, or which item he will manufacture first, then which is the second item, which is the third item. So sequence is important here. The setup cost per change depends on the items presently on the machine and the setup to be made according to the following table. So here what is the decision variable? You see, cost is the decision variable, right? So if he processes each type of item once and only once in each week, so that means to say it is equivalent to visiting all the cities exactly once. How should he sequence the items on his machine in order to minimize the total setup cost? It is nothing but your traveling salesperson problem only. Here we are not finding route but a sequence of items. That's all. So the cost matrix given is, you see that primary diagonal is infinities. So infinity 4, 7, 3, 4. 4 infinity 6, 3, 4. 7, 6 infinity 7, 5. 3, 3, 7 infinity 7. 4, 4, 5, 7 infinity. Right? So let us copy down the problem. First step, row reduction. As usual, first row minimum is 3. Second row minimum is also 3. Third row minimum is 5. Fourth row minimum is 3. Fifth row minimum is 4. So perform row reduction. The result that I get is infinity 1, 4, 0, 1. 1, infinity 3, 0, 1. 2, 1, infinity 2, 0. 0, 0, 4, infinity 4. Last row 0, 0, 1, 3, infinity. Now check whether all columns have zeros. No, third column does not have. So perform column reduction. 0, 0, 1, 0, 0 are the minimums. So subtract. The resultant that you get will be infinity 1, 3, 0, 1, 1 infinity 2, 0, 1, 2, 1 infinity 2, 0, 0, 0, 3 infinity 4, 0, 0, 0, 3 infinity. Okay, now we are ready for allocations. So first column has two zeros. For time being, skip it. Second column has two zeros. Skip it. Third column has a single zero. Make an assignment. So I make an assignment here. These two zeros will get cancelled. So I've cancelled these two zeros. Now coming to the fourth column, two zeros are there. Skip for time being. Fifth column has a single zero. Make an assignment. Any zeros in the same row? No. Now start back from first column. First column has a single zero. Make an assignment. Cross off the zero in the same row. So second column does not have zeros now. Both the zeros are cancelled. Now coming to the fourth row, make an allocation for the first zero that you encounter and cross off the other zero. Fine. Now how many allocations we have got? 4 allocations. For each allocation I am supposed to find out the penalty. Column wise minimum is 0, row wise minimum is 0. 0 plus 0 is the penalty. Coming here, column wise 2 is the minimum, row wise 0 is the minimum. So 2 plus 0 is the penalty. Coming here, column wise 0 is the penalty and row wise 1 is the penalty. 0 plus 1. Here, column wise 1, row wise also 1. 1 plus 1, 2. So here also I've got 2 as a penalty. Here also I've got 2 as a penalty. Whether you travel from E to C or C to E, it is left to you. Arbitrarily, you can choose any, right? Out of these two, you can pick any. The answer will be the same. You need not worry. So I have chosen E to C. Okay, E to C I have chosen. Therefore, C to E becomes infinity. So in the next matrix that I write, this value will be made infinity. So the next problem that I get is infinity 1, 0, 1. Infinity 1, 0, 1. Then 1, infinity, 0, 1. 1, infinity, 0, 1. 2, 1, 2, infinity. This 0 became infinity, na? So 2, 1, 2, infinity. See, 2, 1, 2, infinity. Coming to this row, 0, 0, infinity, 4. 0, 0, infinity, 4. Now, is there a need for row reduction? Yes. Find out the minimums. First row 0, second row 0, third row minimum value is 1. Fourth row minimum is 0. So perform row reduction. I get infinity 1, 0, 1, 1, infinity, 0, 1. Here I get 1, 0, 1, infinity. Next 0, 0, infinity, 4. Now check whether all columns have zeros. First column has, second column has, third column has, but the fourth column does not have a zero. So perform column reduction. So the resultant matrix that I get is infinity 1, 0, 0, 1, infinity, 0, 0, 1, 0, 1, infinity, 0, 0, infinity, 3. So now I am ready for allocation because all rows and all columns have zeros. Now check it out. First column has a single zero, make an assignment. Cross out the 0 in the same row. So this 0 gets crossed. Now look into the second column. I have a single 0. So make an allocation. Cross off zeros in the same row. I don't have any. Go to the third column. I have two zeros. Fourth column also has two zeros. So in the third column, first 0 that I encounter, I make an allocation and cross off the zeros in the same row, same column. These two zeros will get cancelled. Now I am left out with a single 0 in the fourth column, make an allocation here. So now for all the allocations, find out the penalty. Column wise minimum is 1, row wise minimum is 0, 1 plus 0. So here column wise minimum is 0, row wise minimum is 1. So 0 plus 1. Here column wise minimum is 0, row wise minimum is also 0, 0 plus 0. Here column wise minimum is 0, row wise minimum is 0, 0 plus 0. So out of these two, both have the penalty 1. So you can arbitrarily choose any, right? Whether you want to choose D to A or C to B, the choice is up to you. I follow my own logic. My logic is, in the previous case, I had moved from E to C. So now I am presently at C. If at all I get a route from C, I will pick that. So I have got a C route. So C to B I travel. So because I am traveling from C to B, B to C becomes infinity. B to C is not at all there. So nothing to bother. So I have to copy the resultant matrix as it is. Infinity 0, 0, infinity 0, 0, then 1, 0, 0, 1, 0, 0, 0, infinity 3, 0, infinity 3. All rows have zeros, all columns have zeros. Fine, straight away go for allocation. So first column has a single 0, make an allocation. Cross zeros if any, no. Here I have 2 and 2. So the first 0 that I encounter, I make an allocation, cross off this 0 and this 0. I am left out with a single 0 here, make an allocation here. Okay. Now find out the penalties. Column wise minimum is 1, row wise minimum is 3. For this, column wise minimum is 0, row wise minimum is 0. For this, column wise minimum is 0, row wise minimum is also 0. So out of the penalties, 1 plus 3, that is 4, is the maximum penalty. So you are supposed to pick this. I am traveling from D to A. So if at all I am traveling from D to A to D should be infinity. So this value should become infinity. Okay. So the resultant that I copy will be infinity 0, 0, infinity. Infinity 0, 0, 0. Okay. Very nice. Now all rows, all columns have zeros. Yes. Straight away go for allocation. So the first column has a single zero, make an allocation here, cross off this zero. Second column now has a single zero, make an allocation here. What are the penalties? Column wise infinity, row wise zero. Here, uh, column wise zero, row wise infinity. So 0 plus infinity is the uh, penalty on both the cases. Arbitrarily, you can pick any. I go with my own logic, because I had traveled from D to A and presently I am at A. So I will pick the route from A. A to E I will travel. Okay. So when I travel from A to E to A becomes infinity, which is not there. So need not bother. The last part, last matrix that is left is B to D with 0. So B to D with 0. So put across, you travel from B to D. Fine. So now start off with the path from where you started. So the first path that you got was from E. So you have started your travel from E. So from E you go to C. Next, in the next step itself, I got C to B. So E to C, C to B. Now I have come to B. From B, I am traveling to D, B to D. From D, from D I am traveling to A. You see here, D to A. So from D to A. From A, I am traveling to E. So A to E. Look at the original matrix and copy down the values. E to C is 5, C to B is 6, B to D is 3, D to A is also 3, A to E is 4. So 5 plus 6, 11, 11 plus 3, 14, 14 plus 3, 17, 17 plus 4, 21. So the setup cost for the sequence of items manufacturing, that is, the sequence is E, C, B, D, A, and lastly E again. So for this setup, the cost is 21 rupees. Isn't it simple? Hope you people enjoyed. Any doubts, you can post it on the classroom platform. Thank you for your patient listening. Be home and be safe. Thank you. Bye.